Introduction to Synopsys Sentaurus, and it is for course EECS 523. First, I'm going to talk about how to load Sentaurus and how to launch the workbench. So you need to navigate to your desired folder, and to load the default version, you need to type the command module load Sentaurus, and then you need to load Sentaurus workbench by typing swb. So, and then if the folder is run, you need to change the folder and then click OK. And this symbol in the statement means the terminal window will be operate after the program launches. You need to use the module load command in each new terminal window each time before launching the workbench. So here's the terminal, and I already go to the Sentaurus file and load the module load Sentaurus. Then I will do swb to open Sentaurus. And use the long channel folder and click OK. So here is how the workbench looks. Here are the tools. There are SDE as device as visual, and here are the nodes, and here all the nodes and all tool will run. So all the row columns are yellow, and your screen might look different based on the node is running or pending or waiting for running or etc. So each tool SDE, as device, as visual is shown with a matrix code of cells called nodes, and each node consists of input files that are created by the tool to the left of it and output files that used by the tool to the right. The column titled L-Gate contains models for CMOS FETs with different gate lengths. And then after you make sure that all the parameters are correct, you can click Run. And then a window will pops up, and then you can select OK, and then the program will run for about 30 seconds or longer, depending on how what your program is. And you can notice the color change which shows that the node has been run or not. And here are the Sentaurus tools. The Sentaurus editor is SDE, is a 2D or 3D CAD software which creates device structure for simulation. As device takes structures from SDE, applies test parameters supplied by the user, the initial condition, and the parameter simulation. The S-Visual is used to view the result, structures, test plots, and characteristics of structures created by SDE and S-Device. The S-Process is used to mimic the process for building device. And the text editor, S-Edit, compose text programs which other applications use to create structures, test, and etc. And the workbench, SWB, is a framework for calling and organizing the tools. It is not necessary to use the tools. They can all be called directly from the command line as well. And then I'm going to talk about the Node Explorer. So when you double click a node, and it will open a Node Explorer, and the Node Explorer will show all files associated with that node, including input and output. So here is when we clicked on a node, and the window for the Node Explorer is like this. And here are the input files when you click the node input files. So I am going to click on like example 2.2, and here are the workbench, here are different tools, and here are different nodes. And I'm going to select some of the nodes and run, because I don't want to spend too much time on running all the nodes. So I will select these 3 nodes and click run and click OK. And then it will start running. You can see the color of the nodes are changing, and it is respect to like this is running, and the other 2 nodes is pending. So we'll wait for the first node to run. So at the same time, I would like to talk about the different files in SDE, SDevice, and SMesh. So the file is the reference of the file is from the TCAD 3D document, and you can click on properties here and input files, and then you can see the CMD file edit. So here is the CMD file, and you can see the different definition on the files, the gate, source, drain, and substrate, and the channel. So here, this is the SDE CMD file, and then this file is also from the PDF, and also the SDevice. So here there's also some definition for the SDevice. You can set the what you want to be, what the gate voltages are, and the steps are, and also the drain voltage. So now the first and second node is done, and then the color will turn to yellow, and then the third node is running right now. And now the third node is done. Next, we are going to talk about structure editor input output. So you just ran Sentaurus device SDE, which used a CMD file and a PRF file in order to generate a TDR file. The CMD file specifies the materials, 2D dimensions, and meshing details. It can be written by hand using the SDE GUI or generated using the SProcess tool. The PRF file specifies workbench preference and is also a text file. The output of one tool becomes the input for the next tool. So under the Node Explorer, you can read these files by clicking the file names. They are text files and can be edited by SEdit or any other text editing software. So here is the example for SDE file. The CMD file for SDE sent to SDE creates a TDR file. Here is the example file. In the Sentaurus tool, the first one is the SDE and is the structure editor. And like I mentioned before, the structure editor SDE is a 2D or 3D CAD software which creates device structure for simulation. So here is the SDE tool. The column title L gate contains models for CMOS FET with different gate lengths. So here are CMOS FET, and here is the different gate lengths. And then another Sentaurus tool is SDevice. SDevice takes structures from SDE, applies test parameter supplied by the user, and so that includes initial conditions and parameter for simulation. So if you right-click the bottom and then the properties and then input files, you can edit the SDevice CMD file. And the parameters are pthing, AF, and other parameters, and also BD. So for our examples, we will change BD and do some simulation. And for the SDevice tool, there's a note regarding the current. So the parameter area factor is specified in the physics section of each SDevice simulation file. If this parameter is not specified, a default value of 1 micrometer is used. So to calculate current density, take the current values provided by the software in the IV plots, divide by the product of the area factor value and the total width of the simulated device. Convert microns into cms to get ampere times cm squared. So you can also check the current densities using the TDR files. And the next Sentaurus tool is SVisual. So SVisual is used to view the result, structures, test plots, and characteristics of the structures created by SDE and SDevice. The SDE simulation output consists of a binary TDR file, and to visualize it using SVisual, double-click on the TDR file under the Node Explorer. The device structure is shown. There are many different options for plotting a 2D cross-section and 1D cut lines. And for inspecting and analyzing the TDR structure, you can see the SVisual manual or help menus for more info. So here is the example of opening an SVisual. So here you can open a file here, and you can choose different data and select a contact, and then you, for this part you can select a variable to plot and click on x-axis or y-axis below. And the inner voltage corresponds to node voltage, and the outer voltage lists the external voltage for nodes with series resistor defined in the CMD file, electrode section. And here you can decide if you want to plot in log scale. So here, after these three nodes are done, you can choose this three node and right click, visualize, and then select inspect file. Or you can also click this visualize and inspect all files. Here is the as visual window, and you can select all of the nodes, select drain, outer voltage to x-axis, and then select total current to left y axis. And so here is the plot that is shown. So this x-axis is the drain voltage, and the y-axis is the drain current. So based on different gate voltage, we can get different IV curve. So here the gate voltage is 1, 2, and 3. So corresponding to these three curve, the gate voltage of the black curve is 1, and then the gate voltage of the red curve is 2, and then the gate voltage of the blue curve is 3. So the larger the gate voltage, then the larger the drain current is it. So the next Sentaurus tool I'm going to talk about is S-Process. S-Process is used to mimic process for building device. So there are also different parameters like SBD, PMesh, T-die, and other parameters. And there's also here's a D-mesh and ND. And so for the workbench, the SWB is a framework for calling and organizing the tool. And that's the window that we see from the simulation. And if you want to run on some of the nodes, you can click on the nodes, choose the nodes, and then click on the run button. And here, the color means different status of the nodes. So the basic flow of the Sentaurus is like this. First, the SDE. The input file of the SDE is CMD file and PRF file, and it will output TDR file, and then it will go to S device, and it also has input of CMD file and PR file, and then it will output TDR file and PLT file, and it will go to S Visual. You can use S Visual to visualize the plots that you want and do some other analysis. And for this chart, the blue indicates the input files. So the input files are these. And then the black indicates the output files. So the output files are these files. And then the gray indicates the outputs from one step, which becomes input to the next step. It's the TDR file and the PLT file. And here's the reference for this video. Thank you.